in case we run into some issues in the future during this lesson. That might just be why. Okay, so it wasn't just me, it was you guys too? That's really weird. I'm not entirely sure what caused that. I kicked you out. Wow. Alright, so apparently it was just having a real big problem today. At least it, I guess, just wasn't just me. It took 14 minutes to do anything. Wow. Well, I was trying to, I was testing your resolve, if you wanted if you really cared enough to rejoin. Is Inkscape something we can use on a Chromebook? I don't think so, no. I'm glad you did. Because if I remember correctly, a Chromebook runs a version of Unix, but it's Google's own. No worries, Sam. Everybody did. So it wasn't just you. Myself included. The webinar software crashed 3 times on me when I was trying to start up the class. But I appreciate you saying something. But yeah, I'm not sure Inkscape would run on a Chromebook. You can give it a try though. It's still not very happy at me, but at the very least it's running. Okay, gotcha. Alright, well, in the meantime, let me go ahead and put the link to download in the chat box, just so you have it for later. There you go. I believe Wednesday's class, I believe Ms. Saunders put that up on YouTube, and part of it's going over getting Inkscape downloaded and everything like that. Yeah, it's a type of Linux, but I don't know if it's going to be, I don't know how heavily modified it is. It's the same subject as last week, Inkscape. It's true, though. It's probably worth a try. All right, so yeah, continuing along with what we were doing last week, Inkscape. Let me take my hat off and fix my headset because it's falling apart. Inkscape. Inkscape is a vector graphics program. Do you guys remember why they're called vector graphics? It's not named after Victor, no. Good old Victor Vector. It was very hard to understand. How about math? Does me mentioning the word math help at all? Dr. Vector. 4, okay. We're getting in the right direction. 4 is a start. It's your worst nightmare. You just haven't been taught math, right, Tyler? Yeah, exactly, Andrew. Yeah, there you go, Cam. You guys got it. Exactly. Um, a vector in mathematics is just a line. Um, you have a starting point, you have a direction, and you have a distance. And all of these things make a vector, well, certainly the direction and the distance make a vector. Um, like if you ever watch like a sci-fi show or something like that, and they're all like, oh, their vector is about to intersect with ours, blah blah blah. All that means is their speed and their direction. Let's say that this is the USS Enterprise here. But, let's just draw a more traditional spaceship. The flames coming out of the back. There we go. All that means is their speed and their direction will at some point intersect with yours. You and your flying Pac-Man ghost. I don't know why I did a Pac-Man ghost, but we're just going to roll with it. So it's a Pac-Man ghost. And boom, at some point there would be like, a collision there. That kind of a thing. So, the banana spaceship and the Pac-Man ghost would intersect. Or the corn, yeah. Yeah, it also kind of looks like corn. But that's all they say when they're saying, like, their vector is bearing down on blah, blah, blah. It just means that their speed and their direction is such. It's this. They're going in this direction and they're going this fast. Okay. Is it giving you an error message or... anything like that, Tyler? Yeah, exactly. Semi-identified floating drawn object. Whoop, whoop, whoop. Oh yeah, that was another thing that I was going to say. Yeah, for those of you who are just starting up Inkscape for the first time, if you so decide to open it, be prepared for it to take a few minutes potentially to start up the first time. Oh, gotcha. I think you meant poop or popping up, but yeah, too many of them pooping up. Couldn't type. Okay, so yeah, Inkscape is a vector graphics program. Vector is the mathematical term for a line. You don't have to open it up yet. I just want to go over this stuff first. I'm just saying in case you did, that's what's going to happen the first time you try and open it. Now, the thing to take note about a vector in mathematics, is it can be expressed with a mathematical equation. Like that's what makes that's how you can express a vector with numbers, is by using a mathematical equation. You solve the equation and you get a line, you get a vector. So vector graphics, in that sense, vector graphics are simply collections of points or nodes with equations detailing the lines between those nodes. So it could be, like the bend of the this like baby tiger, like his back leg, or it could be his ear right here that could be defined with another equation, that kind of a thing. And that's how vector graphics are defined. Like we were talking about raster graphics last Wednesday as well, which is the other side of graphics, wherein you have a grid of pixels. So like I was talking about pixel art. Pixel art is an example of raster graphics, where you have a grid of pixels and you fill in a pixel at a certain coordinate, and you fill in another pixel, and you fill in another pixel, and you fill in another pixel, and so on and so forth. And that gives you a drawing. But it's all made up of individual pixels. Whereas vector graphics, you have nodes, and then you have mathematical equations representing the lines that connect those nodes together in order to make our weird bow tie thing. Now, the advantage with vector graphics over raster graphics is you can scale them up, you can blow them up, and keep the same sharpness that you have in a smaller version, because all you do is you extrapolate those equations over a larger area. Whereas something with raster graphics like a bitmap or a JPEG or something like that, since those are made up of individual pixels, the computer can't extrapolate, how exactly a larger version of it is going to be detailed. Like it doesn't understand. So all it's going to do is it's going to make those individual pixels and make them larger. So this original picture, if we blow it up with a bitmap, all you do is you see the individual pixels and it looks all weird and hard to tell what's going on. But with a vector graphic, you go, okay, so you have all these nodes and you have the equations representing the distance, like how the lines between those nodes are drawn. You just space the nodes further apart. You extrapolate the equations further, and you have literally the same amount of detail that you had in the original image, just blown up. So that's one advantage of vector graphics. For that reason, it works very well with company logos and stuff like that, because then you can just blow up the image and put it on a billboard, and it keeps the same sharpness that the smaller image would have, and everybody's happy. In addition to that, vector graphics, because they are made up of nodes, you can move nodes as a group, move them around, change the the equations and things like that. Yay, billboards! I know, it's super exciting, and you can create characters with vector graphics that you can then animate in other things just by moving those nodes around. They're kind of like having bones. It's a animation style referred to as tweening, sort of. Tweening is a version of it, but it basically allows you to move the bones around. And yeah, they're the same slides from last class. We didn't get through this whole presentation, and I'm just basically reviewing for those who weren't here on Wednesday. Yeah. So you can animate like characters and such very easily. In addition, vector graphics files tend to be smaller than raster graphics files because they're just a collection of equations as opposed to information about each individual pixel in the picture and what's contained where. So for that reason, a lot of times vector graphics files are smaller. It's not always the case, but most of the time they're smaller. Now, in order to do more complex shapes in vector graphics, more complex illustrations, a lot of times that involves layering multiple different vector graphics on top of one another. So like, again, for this lion cub's nose, you've got the first layer, which is his fur. Then you got the second layer, which are all the shadows on his fur. Then you got the third layer, which is the pink part of his nose. And then the fourth layer, which is the line sort of giving you an outline of his nose. Like if we were to look at his eye and do the same thing with the layers, the first layer would be the fur, the second layer would be the shading, the third layer would be probably just like the yellow part inside the eye right here, and then the fourth layer would be all this black stuff, which are like the lines of the eye and everything like that. So that's how you do more complex illustrations in with vector graphics. Yeah, we did this and this. And we spent some time downloading and installing it last Wednesday. It was a little bit arduous because there is no native version of Inkscape for the Mac. Despite the fact that they have the download here, you need to get exports for it as well so that it can simulate a Windows sort of set of instructions and everything. But regardless, we got them working, and we didn't get to poke around in Inkscape at all. So I think that's what we're going to do today. So again, yeah, let's go ahead. Those of you at home, go ahead and open up Inkscape. And again, if this is your first time opening up Inkscape, it can take a few minutes for it to start up. I'm going to get it open on my computer as well. Now, granted, I've opened it up a couple times already, so it shouldn't take as long, but It'll still take a little while. Okay, excellent. If you already have yours open, that's fantastic. Fantastic. Hello? There we go. Now it's starting up. Maybe. Let's see here. I know I'm being impatient, but I have started up Inkscape since I downloaded it. So, oh no, they're both opening up. Okay. I was just being impatient. I'm gonna end this particular task. All right. And we'll just hang out for a minute while it gets opened on my computer. Because apparently it's been long enough since I've opened it that it has to rebuild the font caches. For those of you who are running it on a Mac, though, keep in mind that the reason why you downloaded Xquartz, yeah, mine is slow, is it's simulating sort of the essential parts of a Windows environment in order for Inkscape to run. So you are basically emulating parts of another computer in order to run Inkscape, which means that you get a little weirdness with it. Inkscape's going to have a file menu, but it's not going to be where the normal file menu is on a Mac. The normal file menu on a Mac, here we go, is going to be X11 instead. Xquartz work for Windows games? Probably not. You might want something like Wine for that, and it depends on what the Windows game is. Your best bet is to partition a part of your hard drive and install Windows on that. That would be the most, like do like a boot camp thing and then install Windows on that partition. But for like older games or for lower end games, things that don't require a lot of 3D acceleration and things like that, you can probably get away with Wine, at least like a Wine wrapper. So once you've spent some time waiting for it, Xquartz should pop up. Should being the operative term here. There are some other things about, we're not going to worry about that right now. We're not going to worry about that too much right now. Okay, yeah, basics of Inkscape. Okay, so like I said, Inkscape is a vector graphics program. Now that means that you can mess around with a lot of the stuff that you make. Now if we're to look over here, we've got like our toolbar. It's got a whole bunch of different stuff on it. You've got like the edit pass by node, tweak objects, zoom in or out, measurement tool, create rectangles, blah, blah, blah. And then here in the middle, you've got like this rectangle. The rectangle represents your canvas. That's the word I was looking for. And if I hold Control and use the mouse wheel, I can zoom in on it, or zoom out, as the case may be. Otherwise, just it scrolls up and down on the scroll bar. I can also click in the mouse wheel and pan around like so. But here's another sort of bonus of a vector graphics program. I drew the square, right? Well, I can redraw the square, the dimensions of the square with its associated weird redrawing issues, even after I've created it. Again, with something like raster graphics, like pixel art or something like that, you would need to, if you wanted to make this rectangle larger, you would need to draw the individual pixels in, or redraw your rectangle or whatever, in order to ensure that it resizes. Now a lot of stuff like paint and things like that will simulate a vector graphics um, kind of thing by allowing you to resize an area like a square that you've created, and it will automatically compute like the pixels necessary in order to fill in the space that you've selected. But it's not going to be the same thing. In this, what we're doing is we're moving the nodes around and we're changing the equations. Not even necessarily changing the equation since it's a square or a rectangle, but we're at least moving the nodes around, and it's automatically resizing itself and updating as it needs to. So I'm going to go ahead and move this up here, and we can look at something like the 3D box. Hey, look at that. 3D box is kind of cool because it allows you to, well, do a 3D box. And with it, you can edit a whole bunch of different aspects of it. Like I can, by clicking on this corner right here, I can change multiple dimensions on the box. I can go so far that the vanishing point goes off to the vanishing point and reverses and comes back around, which is, just sort of a mathematical quirk. Or we could just have it run off to the vanishing point if we were so inclined. And it's a super long box with an incredibly exaggerated perspective. This looks like a fisheye lens perspective almost. Now we've created a three-dimensional kind of triangle, a pizza slice. But yeah, a whole lot of these you can mess around with them. I'm going to change the color. We're going to make that yellow. Yeah, there we go. And as you can see, I can select like the node on the triangle and change it, or the star, excuse me, and change the property of the star. Same kind of deal. Really easy to do because it's vector graphics. I can turn it into like a weird buzzsaw kind of a thing. Like, I can turn it into a pentagon. I can expand it further and turn it right back into a star and do the whole process all over again. And it's really unhappy with me because it's trying to record the screen and render information on it at the same time. But we can do this and just totally mess around with everything. Anyway. Oh yeah, totally. I have no reason to believe otherwise. Researching star properties. There we go. So now we've got our little star design here. Double star. Super bright star. But again, like a lot of this kind of stuff, you wouldn't really be able to do if this were raster graphics. Like we can just extrapolate the spiral and make it less intense, or we can add more at the end if we wanted to. Now over here, we've got a whole bunch of different stuff too. This is kind of like our options menu, which allows us to scale our elements. Allows us to rotate them if we were so inclined. I don't think we can do it to this one, but exactly, Tyler. Exactly. Um, but basically, I mean, it's just a thing that you can spend some time messing around with. You can draw with the pencil tool, and it will. This is closer to a raster, but it'll try to get something to represent it. But as you can see, if we zoom in more, it's actually a whole lot of nodes, and using the equations in between those. So it actually kind of looks wonky up close. Like it looks like I mean, I don't have a steady hand, but good lord. But zooming out, like it looks okay. Like if we were to zoom out and do this, look at that, look at that. But if we zoomed way in and drew a line like so, it looks almost like a straight line once you zoom far enough out. But anyway. The pen tool allows you to make straight lines and polygons with said straight lines. You don't have to make polygons, though. You can make open-ended shapes. You don't need to do any of this stuff, but this is just more sort of some of the things you can do with Inkscape. Got the calligraphy pen. Super crazy, I know. Make an outline of a star. Yeah, I believe you can make the fill empty and then make the stroke a color. So if we do this, change the fill to be empty, you made a flag for when you rule the world. Excellent. Well, hopefully it's a cool flag. Just doesn't want to cooperate with me right now. It's really unhappy. Hmm. Okay, well, that just doesn't... It isn't happy with me. This is a wonderful illustration, though. I gotta say, I'm pretty proud of myself for that one. But anyway, yeah, you can make basic shapes and stuff like that. Really super easy to do. By changing the fill, you can change the different colors you've got. That's another good point. So let's say we selected our star here. Now we can resize any portion of this any way we want, especially if I click and drag this diagonal line here. Now if I hold down Control, it's going to keep the same proportions. So if we drag to make, the width of it longer, the length of it longer, it's going to make the height of it longer as well. So if we hold it down on the side over here, we can ensure that it's going to scale exactly the same way. So it keeps the same proportions that it currently has, which can be useful. Like say we wanted our pizza slice to increase in size with the same scale. We could do that. You want a bigger pizza? Well, we can meet in the middle here. I'm going to click on it again and get the arrows are going to change, and I'm going to rotate it. So now I'm going to have a rotating pizza slice, which is not really meeting in the middle, but it's the next part. If I hold down Control, I can keep it rotating in 15 degree increments. So now our moon pizza is spinning in space lazily. It would probably still be Control for Mac because, again, of the X11 wrapper. You have to click on, see if I click on it, the arrows change. Yeah, my computer does go insane. Yeah, you need to make sure that the arrows are not pointing straight in or out from the, into or out from the shape in order to change it to rotation mode. Yeah, also using the selector tools, you can input exact values if you really need that kind of precision, which sometimes you might. Well, this is another good point. Yes. So if I select an object right here, you see these 4 buttons I've got. Lower selection to bottom, lower selection 1 step, raise selection 1 step, or raise selection to top. This allows us to order the drawing. So I can move it down 1 step and now it's behind the blue star. If I move it to the bottom, it's underneath everything. If I move to the top, it's above everything. So I can move that star above the spiral, I can move the gold star above the blue star, and now everything's sitting above the spiral. Conversely, I can move the spiral to the front, and now, as you can see, it's overlapping the stars, versus where if I move it to the bottom, and then now the stars are in front of it. That's just, wow. That spiral, though. Yeah, it's a little intense to look at that closely, especially if we were to rotate it. Erasing is mostly just done by hitting the delete key. Again, because it's all about, yeah, because it's all vector stuff. I mean, you could remove individual nodes, but again, it's the same kind of deal. Oh, wow, that's actually an excellent example. If I zoom way in on this this thing that I drew, you see all these little gray sort of diamonds and squares and stuff like that. Yeah. What do you think this stuff is? What do you think these individual things are? Exactly, they're all a node. I can change the drawing by moving nodes around. So if I really wanted to, and I had the time on my hands, I could spend time straightening out this drawing by straightening out the nodes. Bring this one up. And see, eventually we'll get a nice pretty straight line no matter how far we zoom in, because I mean, that's a painstaking process, but it's totally doable. This is probably actually a better example. By messing around with the individual nodes, we can turn this into a rectangle, like so. Pretty cool, eh? Although I have a pretty weird idea of what's cool. Thank you. I'm proud of it. Create all sorts of weird abstract art thanks to vector graphics. Yeah, it doesn't work out so hot. Yeah, what was once a nice calligraphy line is now this messed up non-Euclidean bouquet kind of a thing. I don't know. That's true. Okay, we'll go over that as well. This is mostly just sort of a features of Inkscape. We're actually going to spend Wednesday turning a raster image into a vector image. And hopefully that should be interesting. So let's see here. Let's select our two triangles. And I'm looking for a specific... What does it look like? Oh, it's not visible on mine. Because it's over here? No, it isn't. Where did it go? Oh, here you go. Okay, so mine is on the right side. Yours might be on the top of the screen. It might be somewhere else, but you see these three rectangles of varying sizes with a red line off to the left. If I mouse over it, it says Align and Distribute Objects, or Shift-Control-A. I'm going to click on that, and it's going to bring up this menu over here on the right-hand side. So now I can align all of the objects, you know, to my to make my life easier. So I can align it vertically and horizontally. So now that the stars are aligned, which helps you to clean up a picture, that sort of a thing. Or I can align it by the bottom, or I can have, I can flip them over the line. I can move them back up. Let's move them back up. I can align them by the top, align the left edges. Let's recenter everything. I can also distribute them equally so that they're all, like the left edges are the same distance apart, the center is the same distance apart, things like that. The stars are all aligned. But yeah, essentially it just allows you to sort of clean up your picture if you're trying to make something that's perfectly aligned like this. This doesn't really look like it, but that's because the two stars are two different sizes. So if I were to just do this one and make it a little bit larger, I'm going to try to select the one behind it. Now let's try and... I got a lot closer to it, but it still looks pretty messed up. Anyway, if you were intent on it, you could spend some time aligning everything and making it look all nice. You can duplicate objects really easily, again, because they're all vector images. All you do is it just gives you another set of nodes and equations and places the nodes in a new space. Now, I know we went over this last Wednesday, but in case you weren't here, I want to spend a little bit of time talking about this too, because this is pretty cool. Vector graphics lend themselves pretty much perfectly to laser cutters. And those of you who were here on Wednesday, I already spent a lot of time talking about why, but those of you who weren't, or maybe if you were, why is that? Do you remember / do you have an idea of why that might be? They don't change shape as they change size. Yeah, there you go. There's one of them. You don't gain or lose fidelity as you change the shape of it or the sides of it too. Yeah, exactly. It's easy for cutters to go from point to point. All of these things make it. I'm not sure how to take that, Gavin. Yeah, but it's that's how cutters operate is they go from point A to point B to point C to point D, blah blah blah, all until the cut is complete. And it's all about finding the number, like finding the next node and moving to the next node in the cut. Um, which lends itself perfectly to vector graphics because that's exactly how their sort of the equations for drawing them is set up. Move from one node to the next. This is how you move. Because cutting laser cutters, things like that, are all about moving from node to node. And because vector graphics already have that information, all you have to do is just add more nodes on a vector graphics file, input those into a laser cutter, and then the laser cutter can suddenly cut with as much or as little fidelity as you'd like. And if you were so inclined and you had the time, you could have it cut an exact replica of something you made with vector graphics. So, you got your lamp shade or your headboard or, your dress, because I know you guys are huge on making dresses. Who knows? You might be. I don't know. This was made with a wood burner. This guy's face is on a piece of wood. Believe it or not, it's actually burned on using a laser cutter. Laser cutters lend themselves pretty well to cutting out things that were created in vector graphics and vice versa. Amazing, Sam. Amazing. Also, I still just think it's awesome that we're at the point where lasers are just, we use lasers. For projects. But yeah, you can use them to cut and engrave. Yeah, exactly. Lasers are just the thing now. You can use them to cut or engrave or etch away some material from something. Like we've got, yeah, using raster graphics, they were able to create this sort of burning design in the wood. Yeah, household object. So they took this image, converted it to a raster image, and then used that raster image in order to burn a design onto the wood, which was this dude's face. And it actually comes out with pretty good fidelity, considering. Well, vectors are good for cutting, though, so you can create this uh, little Ferris wheel kind of design that presumably spins using vector graphics. Vectors are also good for engraving, so you engrave this um, scorpion design onto a piece of wood or a piece of plastic or whatever. And of course, if you were so inclined, you could test out and see, based on how fast you move the laser cutter and how much power you have going to the laser, whether or not you would, make a light uh, a light sort of burn on the wood or a deep dark burn on the wood, um, or just set fire to the wood. Not suitable for etching. That just basically means here, at these speeds and at this power, um, you would just set the wood on fire as opposed to actually etching anything on it. Yeah, it's just some examples of stuff that you can make using a vector graphics program and then sending it to a laser cutter. Can it set fire to the rain? It's possible to set fire to bodies of water, but it's not really, like, it's not the water that's necessarily catching fire. So, not without some additional materials. Yeah, that's true. Are we going to use laser cutter this year? That's an excellent question, Gavin. I'm not entirely sure. I know that laser cutters were a big thing last year, and I believe even last semester. But this year, I couldn't tell you. I'm not really sure. Oh, look, a serious question. Surprising. Yeah, fair point. Not sure how to take this. Do you mean it? But yeah, um, these are some of the things you can do with Inkscape and laser cutters. They're rare. They're rare. If you were really in love with this design, you could etch this onto a piece of wood, and it would be, well, you'd pretty much only see like this, because you wouldn't see the Y, the young engineers or the hello or anything like that. So you'd have some sort of weird kind of ribbon coming off the side, and you'd have a rectangle and a pizza slice and a couple of stars, and then another rectangle up here. And that could be etched onto a piece of wood, and you could take it home and show it off to people and be like, hey, look, I made this. And they'd be like, well, all right. But it would totally be doable. And you could actually make like a nice design, unlike what I made here. And yeah, Mom, get the camera. You could actually make a nice design, something that you would actually be pretty proud of, and it would be pretty awesome. With this pentagon all set up. There we go. With another star. This is my stylized American flag. I don't think I could fit 50 stars in here. Hey, there you go. Yeah, you could do that. That would be a lot of work, but that would be actually really awesome. And on Wednesday, we're going to go over vectorizing raster images. So if you're so inclined, you could theoretically use that process in order to create something that would be good for engraving onto a block of wood. I'm sure there are better processes out there than the one I'm going to teach you guys on Wednesday, but made an ingress card? Nice. How did flaming balls of gas get associated with five-pointed things? Actually, a lot of that has to do with poor eyesight. That's the prevailing theory, is that people would see the stars twinkling up in the sky, and they didn't necessarily have good eyesight, and there wasn't really corrective lenses or anything like that, so they became five-pointed stars. Yeah, you could do that too. Um, but with the advent of like telescopes and corrective lenses and things like that, people pretty much widely acknowledge the fact that you know gigantic fusion reactors are sort of spherical and not really five-pointed stars. 44, 45, 46, 47, 48, 49, and 50. Thank you, Cam. There are my 50 red stars on a blue background. This is the United States, more in your face and extreme. It seriously looks like something out of like the late 80s, early 90s. Hey, Sam, don't say things like that, but I know you were kidding, but yeah. Um, yeah, that pretty much is going to do it for today. Like I said, we're actually going to mess around with vectorizing raster images on Wednesday, which should be a little bit more hands-on and in-depth than today's. And it should be certainly more interesting. Yeah, no problem. I will send out the poll questions, and then once those are done, we'll do question and answer time, and we'll meet up again on Wednesday.